Hello everyone, this is Flip Notes on Unit 1, 1.2. So we are officially starting our next section of our workbook. But before we get into this section, into the new learning, we're going to make sure that we are solid on our function notation skills, which is why, as you notice, in the big capital letters here it says refresher. It says function notation is a way of representing functions algebraically. Function notation makes it easier to recognize the independent variable, or the input, and dependent variable, the output, in an equation. The function f of x is read f of x and indicates that x is the independent variable, or the input. And here we have an example where we can compare side by side, evaluating with function notation and without. So we have an example. It says Milan is starting his own clothing company. He tells a buyer that the cost of ordering shirts can be calculated using the equation, and here we have y equals 8x plus 15, where each shirt x costs $8 and a flat rate shipping cost of $15 is automatically applied. Calculate the cost of ordering 4 shirts. Notice here on the left it says without function notation. So we have our original equation, y equals 8x plus 15, to find our variables, x and y, and now we write out in words, let x equal 4, because we're looking to see the cost of 4 shirts. So that's why we wrote this. And so wherever we see x, we are plugging in 4. 8 times 4 plus 15 becomes 32 plus 15, and then we have y equals 47. Notice the question in the box right here. It says, 6 months from now, how many shirts did they buy? So, for example, if I were, let me see if I can put in a shade here for a second. Let me see. Let's say all you saw was this, and you saw this number in your notebook. 6 months from now, would you remember how many shirts you bought? Probably not. You would remember, hey, look, I spent 47 bucks, but nope, I don't remember. So now let me get rid of the shade. And let's compare when we use function notation. So now it says with function notation. So notice, instead of writing y, we are writing f of x. These mean the same. F of x means y. So we have f of x equals 8x plus 15, where x equals the shirts. And now notice, instead of y, we're saying f of x equals cost of the order. But in your brain, in your mind, I want you to still imagine that that says y. But instead of saying y, we're saying f of x. We are letting x be 4, but notice nothing here says let x equal 4. Instead of having to write that out, we now have a notation that will keep track of that for us. Right here, where it says f of 4. That's how I would say this out loud, f of 4. And this is a set of directions. Wherever I see x, I'm plugging in 4. So it became 8 times 4 plus 15, 32 plus 15, and we still get the same answer of 47. But if I put the shade back, and I go like this, if I asked you, and I showed this to you right here, and I said, in 6 months, how many shirts did you buy? 6 months have gone by and I say, this is what you know, how many shirts? And if you look right there, I have kept track of my input. I kept track of what I plugged in. This says f of 4 equals 47. So I could say, hey, 6 months from now, I know I bought 4 shirts. So that is the big idea. Function notation is a way of writing the y value where it keeps track of what we plugged in. Let's practice. Number 1 says, use the equation f of x equals 8x plus 15. Let's keep our good habits going. I see an equation, so I'm going to highlight it. To evaluate the function at each value, explain what each means in terms of the real-world scenario. So I'm going to only be doing 2 of the 4. I want to make sure that I stick to my time limit for the notes. So what I mean by that is, instead of doing A and B, see how A and B, I'm just going to do A, and I'm only going to do C. I'm going to leave these 2. If I have time, I'll come back, but we'll see how we do as we move through this notes video. So let's get going on A. It says f of 9. In my brain, I'm remembering the notation is f of x. So that means that 9 is a value for x. So wherever I see x, will be plugging in 9. So this becomes 8 times 9 plus 15. I'm going to draw a line down my equal sign to keep everything lined up. 8 times 9 is 72 plus 15. If you want to use your calculator right now, go ahead to do 72 plus 15. I would challenge you not to. If you don't know it right then, over here off to the side, actually, let's do it out together. So 2 plus 5 is 7. 7 plus 1 is 8. And we get 87. Now for C, again, if I think of f of x, well, notice this says f of x equals 175. This is when it's important in our brains to remember that f of x means y. So I'm being given a value for y. Which means when I go look at my original equation right here, f of x, this entire f of x piece becomes 175 equals 8x plus 15. And now I'm actually going to solve for x. And now we need to go back and think of our Algebra 1 two-step equations. I'm trying to get this x term by itself, and I pay attention to this side because this is where x is. Is there something I could add or subtract first? Well, I see this plus 15, and I know the opposite or the inverse of adding is subtracting. So I will subtract 15 from both sides. Again, if you haven't gotten your calculator yet, we will be doing quite a bit of solving, so it would be good for you to go get it. Or if you're comfortable doing 175 minus 15 without a calculator, that's great too. So I'll pretend like I am doing it without. And I get 5 minus 5 is 0, 7 minus 1 is 6, and then I bring down the 1. This says 8 times x. The opposite or inverse of multiplying is dividing. So multiply both sides, divide both sides by 8. I'll use my calculator for speed here. 160 divided by 8 is 20. Mental math trick for those of us that like mental math here. For a second, I could have ignored, don't do this, but mentally, don't look at the 0 for a second. 16 divided by 8 is 2, and then I add my 0 and I get 20. Or just use your calculator. 160 divided by 8 is 20. So A and C are very different. That's actually why I put them in different colors. In A, I was given x, I was given a value for x to plug in, and I actually found my y value. F of 9, or y equals here, you found y. C is the opposite. Here I was given a value for y, and I solved for x. So let's practice. In numbers 2 through 5, our directions have changed a little bit because if you look at number 2, I'm actually asked to find two things. It says find f of -3 and f of x. So I'm actually going to ask you if you're comfortable, based on the two I just did, to pause and try these. Pause, try them, and then you can press play and compare answers, or let's get going and try them together. So f of -3, that's giving me a value for x, which means wherever I see x, I will plug in -3. So -6 times -3 plus 4, that's 18 plus 4, which is 22. If you want to write a note, you can write given x, found y. Here, this is giving us a y value. So I say 16 equals negative 6x plus 4. And now I'm solving for x. So I need to subtract 4 from both sides. And I get 12 equals negative 6x. I will divide both sides by negative 6. And I get x equals negative 2. So here, in this one, I was given y, and I found x. Again, I'm only going to do 2 and 4. We'll leave 3 and 5 alone for right this second. If you want to give these a try, feel free. Make sure it's in pencil so that when we come back to it to talk about method and answers, if we need to make a couple of adjustments, we can. Number 4, ooh, check it out. Now we've got a quadratic, and we should all be super excited because we are experts. We've been working on this with our bell ringers. So h of negative 5, I'm being given a value to plug in for x. So this becomes negative 5 squared plus 1. Again, if you're confident to finish this part, press pause and try and see if we match. Negative 5 squared is 25 plus 1, and I get 26 as my answer. H of x equals 17. I am being given a value for y. So I'm going to set 17 equal to x squared plus 1. And let's solve. So I see that I have a positive 1. I can subtract that over. Blast from the past. How are we going to solve this? This is x squared. The inverse operation. I'm just going to put, I'm going to say this for like squaring, is taking the square root. And I'm hoping as soon as I drew that symbol, we're like, oh yeah, I remember that. So let's do that. We're going to take the square root of both sides. Whenever we take the square root, we always get 2 answers. I get a positive and a negative 4 because the square root of 16 is 4. Real quick, the reason we get 2 answers is that if I'm looking at this equation, x squared equals 16, there's actually 2 answers that make that true. 4 squared is 16, and negative 4 squared equals 16. So that's why when we take the square root, we have to put that plus minus because we get 2 answers. Moving on to talk about tables. Tables is great because we actually have no math to do. This is purely a, hey, check it out. I've got this list of inputs and I already have my data, my y values has already been input into this table. So let's read it. The function h of a, notice how I read that, h of a represents the average height of boys that are a years old. Use the table to evaluate the function at each value. Label your answer. Let's take a look. So h of 7. So this is giving me a value for x. So I go to the input table, which is x, or actually let's be a little more concise. So it says a years old, that's x. So this is a value for a. So a is the boy's age, and then it says h of a is their height. So I'll label it correctly. So I go to 7 years, and I get out 49. And it says to make sure we label, so 49 inches. Let's do one more. H of 11. So I find 11 on my table right here. and the height is 57 inches. And again, h of a, I was given a value for a. But now if I look at E and F over here, this is a little different. It says h of a equals 61. So this is giving me a value for y. Mentally see h of a as y. So it's saying y equals 61. What's x? So now we're going to go to this column first, and I find 61. So now we're going this way, if you like the arrows we've been using. I'm saying, I know this. And now I'm looking and saying, ooh, okay, if the height is 61 inches, they are 13 years old. Try h of a equals 36. So we're saying the height is 36 inches. I'm hoping we've gone over here and we're like, ooh, okay, there's 36 on the output h of a side. Means that the boy is 2 years old. The other 4 I will leave for you to try if you would like, but this is it. This is all that we do with our tables. So it's really about just understanding, are we being given an input or an output, and how to use the table correctly. Graphs. Knowing how to use function notation with graphs is super important. It's going to come up all year. You'll definitely see it in the future. So it says the function d of t represents, shouldn't be there, represents Gulliver's distance from home after t hours. And so here's his trip. So he starts here. He's at home, so no time has gone by. And over time, he's getting farther and farther, kind of takes a break, a little farther, speeds up far, far, far. At this point right here in time, he's the farthest away. And then he turns around and he progressively starts getting closer and closer and closer and closer until he gets back home. Let's see what we're asked to do. Number 7 says, use the graph to evaluate the function at each value. Explain what each means in terms of the real-world scenario. My first thought is it says d of 2. So we're saying x equals 2. What's y? D of 2. We have to use that. So we're saying I know that x is 2. This is where I'm looking at my graph. When x is 2, I use my pencil to kind of just visually trace up and say, here, I just hit the graph. The answer is 4. And you don't have to write on the graph if you don't want to. You can just watch what I do with my marker here. I say, okay, I know my input is 2 on the x-axis. Let me go up to the graph. Oh, here's the graph. And then I go over and I say, where was I on the y-axis? I was at 4, and the label is miles. So 4 miles. But I was asked for the full meaning. So 2 hours into the trip. He's 4 miles from home. And that's it. Let's do one more, d of 5. So once again, I know my x value. I know how much time has gone by. It's saying 5 hours has gone by. How many miles away is he? So once again, I say, here's 5. Here's 5. And I'm going to go up, up, up until I hit the graph. Here we go. I just hit the graph, so now I look to see where I am on the y-axis, and I see I'm at 11. So now he's 11 miles. And I'll let you update your sentence. So 5 hours into the trip, and you can finish that up. He's 11 miles from home. I'm just going to make a quick mention about 2.9. I'm not going to do it, but I'm just going to mention how you'd approach that. Remember that it says 1, 2, 3, but all of these numbers in between exist. Like this is 1.01, 1.1, 1.5, 1.55555. So to look at 2.9, here's 2, here's 3. 2.9 is going to be right before 3. And then you would do the same where you would look up to see when you hit the graph. But let's come over here to number 8. It says calculate the value of t that makes each equation true, or let's say the function. Well, function or equation. Explain what each means in terms of the real world scenario. If you don't like function or equation, you can say function. D of t equals 2. So just take a moment. You don't need to highlight this, but I want to highlight it to draw your attention to it. Notice the difference between the notation here and here. On this side, here, d of 2, I was given a value for x. On the right, this is the same as saying y equals 2. So this is given value for y. Go find x. Now we're actually going to be starting on the y-axis. This means y equals 2. So now I know how many miles away he is, and it says, let's see, here's 2 miles. And now I'm actually going to trace across to see where I hit the graph. I hit the graph here, but look, if I keep going, I hit the graph one more time. So that means that this actually has 2 answers. 1, and this is about halfway, x equals 9.5. Halfway between 9 and 10. So this has 2 answers. Let's reason on what that means. He is two miles from home. At hour 1 and hour 9.5, or the first hour and then 9.5 hour mark, however you would like to write it. And if we think about this situation, it kind of makes sense that we would have 2 answers, right? Because here's his home. So if he's taking a bike ride and he's traveling, he at one point on his way away from his house to wherever he's going, he'll be 2 miles away. But if he's returning home, at some point he's going to turn around and come back home and be that same distance on the way back. So he hits the 2 miles on the way back, on the way away from his house, and then again one more time on the way back. Let's do one more. D of t equals 5. So again, as soon as I see d of t equals, my brain automatically says y equals. I'm being given a value for y. So I go to the y-axis and I say, hey, check it out. There's 5 miles. And I trace over. But I had to keep looking. There's one answer. And, oh, look. We got one more. So now I look down and I say 4 and 8.5. X equals 4. And x equals 8.5. And I'll, again, just like I did with the F question over here, part F, I'll start this with you and then I'll let you finish it. He is 5 miles away. When and when? Very nice. That's it. So again, notice no math involved, just like the tables where we just need to understand how to use function notation correctly to read the table. Here, we're using function notation correctly to read the graph. This is extra practice, which will be part of our in-class debrief. If you would like to get a jump on giving it a try, you are more than welcome. But that wraps up our flipped notes. Let's see where we are at. 25 minutes, that's perfect. Fantastic. If you have a couple extra minutes, it would be cool, while this is all fresh in your head, to maybe go give these others that we left blank a shot. Here, like numbers 3 and 5. And here's a couple table ones you could try, and then the graph ones. If you need to go back and make up the video from last night, no problem at all. I would ask that you actually stop here with these notes and go make up what you need to from last night, or do both if you have some extra time. Have a great night, everybody. Look forward to seeing you in our next class. Bye-bye.